Hello and welcome to the first online virtual meeting. In this meeting we're going to be talking about Java reverse engineering. We'll go over a little bit about how Java works, what techniques and tools we can use to reverse engineer a Java program, and then at the end we'll have two examples to sort of get you started on how you would approach some of the challenges that we'll have online. So to start, a little bit about how Java works. Say you have a Java project. This is going to contain a lot of Java files. Each one of these Java files will be compiled into a .class file, and this all will be placed into a .jar file. And this .jar file represents the executable. This is the Java executable, and it's the thing that you can click on to run your program. But actually, what this file actually is it's just a fancy zip file, and you can unzip it with any sort of zip utility like WinRAR, and inspect its contents. And what you'll find is that it actually has compiled classes and metadata. And these compiled classes are just the .class files. There will be files with the .class extension inside the jar, which is just a zip file. And each one of these represents a single .java file. And they contain the JVM, which stands for the Java Virtual Machine bytecode for each of the methods and classes within the Java file. This is what the JVM uses to execute the Java code. So the jar also has metadata, and this is relatively unimportant. It's just a specific file in the jar file. But it basically the most important part of the metadata is just to tell the Java virtual machine which class to load first to find the main method. Okay, so let's talk about how we reverse engineer Java. Luckily for us, because of the way Java is designed in the bytecode around the Java virtual machine, its decompilers are extremely effective. So we can turn bytecode back into Java very accurately. Essentially, if we have a hello world program and we compile that to a jar file, we can use one of the tools like, here I've listed a couple popular Java decompilers. We can actually turn this jar file almost identically back into its original source code. This is really convenient when you are working with a Java file or a jar file that is not obfuscated. However, when a jar file is obfuscated, it is much more difficult to decompile. So obfuscation techniques often will rename variables. They will manipulate the control flow to try to break decompilers by adding code that's never run, a lot of switch statements or exceptions, catching exceptions that are unnecessary. They might encrypt strings, and they intend to break decompilers such that they write bytecode that cannot be directly mapped back into its original Java. And so when one of these popular obfuscators are used, what we have to instead use is a deobfuscator first. And so this essentially just reverses the obfuscator's process. And it might decrypt strings, it might remove unnecessary code, it might simplify the control flow, such that our decompilers may work at the end of this deobfuscation process. However, certain aspects of the original program are lost when an obfuscator is run on it. For example, even though we can recover the original functionality of the program, the variable names that were renamed are permanently gone. So also are the methods names that are and the class names that are renamed. So the best that we can do is just infer the variable and method names based on what we can inspect the functionality through the decompiler. So I've listed here two, or actually it's just one Java deobfuscator, and the other one is just a GUI around this deobfuscator that is extremely effective at deobfuscating some of the more popular obfuscators such as ZKM, Aleatory, and ProGuard. Okay, so now let's talk about specifics. How would we go about, let's talk about how exactly we would go about reverse engineering a couple of these challenges. So my first suggestion would be to download Bytecode Viewer. We're going to do this in the example. Bytecode Viewer is a program that is very easy to use, and it puts all the decompilers in one place. So all those decompilers I talked about, they're actually shipped with Bytecode Viewer, and so that you can actually view multiple decompiled results in different panes. You can also use this to reverse engineer Android APK files. And so we'll be using that in an example coming up. But again, like I've said, if the program is obfuscated, we must use a deobfuscator. And the recommendation for that is this deobfuscator GUI. This will be able to reverse ZKM, string encryption, and various other obfuscation techniques really effectively. And this will also be used in the example coming up. But one last thing to note before we get to the example is that if deobfuscator GUI doesn't work, and several other open source deobfuscators do not work, it could be that the jar that you're working with has custom obfuscation on it. And so what you'll need to do is actually use a bytecode library such as ObjectWeb ASM to directly manipulate the obfuscated bytecode to reverse it back to a somewhat more sane output. And you'll often see this sort of thing in CTF competitions where commercial deobfuscators will not actually work effectively. Okay, so with that being said, let's take a look at a couple examples. And the example that I have for you all today is a very simple Java program. It does exactly what you'd expect. It just loops 5 times, prints hello world followed by I at each loop. And I've exported that to demo.jar here on my desktop. So I can run that with this expression here, and you can see it works exactly as we expect. So this is going to be the subject of our reverse engineering today. We're going to try to reverse engineer it. So the first step to do is, by the recommendations, download bytecode viewer. And we scroll down to download release, and then we click this .jar here, and I already have that on my desktop here. And so if we then run that, we can just drag our demo into bytecode viewer and expand the packages, and notice that bytecode viewer does an exceptional job decompiling this bytecode back into its original program, which we could see is near identical to our original source. If you want to inspect the actual bytecode, you can see it here on the right side. You can also notice the metadata, which we talked a little bit about in the slides, and this just specifies the main, which class contains the main method. Okay, so then I also included here an obfuscated version of our program, and when we load this into our decompiler, we can see that the class has been renamed to A, and it's also not immediately clear what this functionality is, and we can also notice that hello world has been replaced. Actually, hello world is here as an encrypted string, and so this is some form of obfuscation. So then the next step that we must do, according to the recommendations, is to download a deobfuscator to tackle this problem. And so the deobfuscator recommendation is Java deobfuscator GUI, which when we go here, notice that we first must download the deobfuscator.jar from this project. And so, for whatever reason, the download link seems to be broken at the moment, so what I've done is included a download link as a mega link here. So you can just go ahead and download that deobfuscator here, and then I also already have that here on my desktop here, so I don't need to include it now. But going back to the deobfuscator GUI, we can download the GUI at this release page and just download this file. And again, I already have this on my desktop here. So then, I'm also going to launch deobfuscator GUI, and we're greeted with this prompt. We're going to specify the obfuscated jar, and then we're going to specify a new jar to write it to. I might just call this deobfuscated. And what we can do is we can actually detect the form of obfuscation here. So when we run this now, we can see that it prints out some suspicious CLNet, maybe some Zelix classmaster string encryption, and that's actually exactly what this is. So I did use ZKM, which is Zelix classmaster, to obfuscate this jar, and so it's suggesting that we use these sort of transformers to deobfuscate it. So we'll take its advice, and the first thing that we're going to do is apply the ZKM, which is Zelix transformers. So we're going to select all except the simple string encryption, because if you notice in the detect it said to use oh, actually we are supposed to use the simple string encryption. Cool. So we're not going to use enhanced string encryption, and we can put those all to the right side, and then we're also going to select all the general afterwards. So select all general, put those all on the right side, and then we're going to uncheck detect and click run. So now this is going to run through the deobfuscation process, and it's going to write to our new file. So here is our new deobfuscated jar. We can see that now if we run our deobfuscated jar, we see the exact same functionality. And if we load it into our decompiler, we notice that the hello world has been decrypted. And so while even though this still remains, and the functionality is not perfectly clear as it used to be, now we can at least get some insight into what exactly this will print. And so with that, go ahead and take a look at the challenges, and good luck.